We're going to go ahead and look at using Venn diagrams to solve application problems. So here's the set of questions. I'll zoom in real quick and zoom back out. Asking you, given this information where the A represents apples, B represents bananas, and then U represents a universe of as you look here, a universe, meaning that there are some types of um, fruits that are not apples or bananas, and there'll be 13, right? So we're really analyzing the cardinality. And so these are the application problems. Again, cardinality means the number of how many are in each set, right? So asking how many packed apples, right, given this situation here. Well, let me make sure we get the setup right. Imagine that the above problem was really a model for what kind of fruit a group of people packed in their lunches. A is for apples, B is for bananas, right? Um, Assume apples and bananas are the only kind of fruit available, then answer the questions, right? So we also, again, have some 13, which are not apples and bananas, are not part of that, those two fruits. So looking at these questions, how many packed apples, how many packed bananas, how many didn't pack apples, you might be able to figure that out just by thinking about it, right? So how many packed apples? We can see 25 and 18. Now, some people did both apples and bananas. That's why the 18's in the middle. 25 represents there were 25 people who packed only apples. The 33 are there are 33 people who packed only bananas. How many packed bananas? This 18 also packed apples and bananas. But when I asked how many packed bananas, we would then add 18 plus 33. Now, as we answer these questions, there's an equivalent set notation operation in notation. N of set A, that means how many people packed apples, how many are in the A set. And so you can see the answer there, 25 plus 18 is 43. N of A complement means how many didn't pack apples. And so that's everyone outside. This 33 and this 13 did not pack apples. That's 46. So we really want to see that this notation, this one that kind of looks abstract or complex, right? Things like this are really answering a real world question. How many packed both kinds of fruits? That will be the 18. Letter E goes with the number of A intersection B. That's the number who did both. So that's what I want you to look at when we think about this notation. It actually means something. So let's just look at a few, but I want to make sure you have all the answers there to look at. But let's look at a few, right? A, complement of A is all of this shaded region. Complement of A is all the people who didn't pack apples, and you could see that would be 13 and 33. A union B, complement to that, right? A union B is everyone here. The complement of that would be, where's that A union B? This one here, G, which is how many didn't pack either fruit. That means A union B are all the people who packed fruit. The complement is everyone who didn't pack fruit. Remember that complement is all the values not in that group there. And so you could see that would be 13. That's where I got the 13 there. How about A minus B? Here's the image. A, and then take away everything from A that B has with A. And so when I pull out the B here, you're just left with this component, which is 25. What is that? The number of A minus B is 25, but that's letter F. That would be how many packed apples only. A apples minus anyone who packed bananas. That's what we're doing. And there was only 18 that had bananas and apples. So those people come out. So I'm left with 25. So take a look at the solutions I have here, compare them to here, and hopefully you'll see, again, the notation matches up with the real world problem based on these sets here.